Thank you. Appreciate it. Hope you're having a good day, man. Okay, let's start this ETL process. Wait. I should not be doing it inside this. I should be doing it inside a sandbox, which is going to abstract the actual core logic for me, And then I can start coding back inside here. So it's almost like as if I need three things. Okay, so here's what I'm trying to do. I'm trying to code an ETL. There's a standard ETL process with a class, and there's a ETL bare bones process that does not involve uh, too much or as much, you know, which is where this mini ETL comes from. So I want to practice proficiency without like helper on the code, and then anytime I need to run it with the test run, right? So it's like there should be a source, like a working source, and then a runner. I'm looking for a runner. So it's like three things. I have this, which is my sandbox where I'll type the code. And then we also need this Python script, which is the runner that just tests that this is actual working code. And then we need the actual model. So you have the sandbox, we have the runner Python, and then we have the working code. So what I should do is to have the working code, like the ETL stuff. And I guess that's where ETL Python 1 comes from, right? This one here. There's some nuances, right? But ideally, I think it's like this. One problem I have been having, I don't know if it's a problem, more like a dilemma, is implementing with like simplicity with things like list comprehension versus implementing it bare bones, because I don't want to fall into the trap of getting sucked into things like, you know, sorted, even though that's out of the box, right? But things like list comprehension, right? If you want to spell this out, then write actual functions that would do these things. So I want to remember, make sure I remember I'm doing those too, right? Like vanilla Python. You know what I'm saying? I'm using these lives as a way to catch my thoughts, look back, see how I did. I'm going to set a timer to try and get this done in 15 minutes. Basic same thing over and over again so it becomes muscle memory. Um, that's the class, and then we'll go with the ETL process for it. This test run is blank, so yeah, that's good. Exactly what we want. But for what it was before this point, I need to make sure that that stays intact. So I'm going to rename this function into like mini ETL. Yeah, yeah, I think this is way better. This is our standard model. You also need a vanilla one too. I guess I can ask, I'll try and implement it myself, then I'll ask AI to review my code of how vanilla it is. But first, let's make it work, then we can make it pretty with like non-simplified stuff. Then we can make it better. Okay, let's get to it. So we have class, ETL process. Need to create a constructor for this thing. What does the constructor take? What should it take? Take the clients, possibly. Self.clients equals to clients. We need to say self here because that's what allows the class to access its objects. I'm going to create the boilerplate extract. Should put self in all of these. Just say pass. I'm going to duplicate the same thing for the rest. Just because. Space in between. Extract. Transform. Load. Now we need to create our function if name equals to name. Then we're going to define our thing here. So we say ETL is equals to ETL process. We're going to define our clients. So our clients are here. Let me see. Okay, where are we at? ETL. What do we want to do with this ETL process? We want to extract. What I was saying before, we need the clients, right? So this is our data source. These clients is Python. We need to indent time. So the indentation should be good. ETL as extract. Oh shoot, I forgot the time. So if I said 5 minutes, shoot, I need to try and set this to 3. I'm not doing this in 3 minutes. I'm not that good. It's not yet. To extract, we want to pass in clients. Alright. Actually, no. Because we already set the ETL process to do that earlier. Now we need to access this, so we need to say e is equals to extract. And we need to print that it's actually extracted properly, so just say e. I'll double do this. Interest of time. Say extract. This is the extract. We could do printf, but you know. T is equals to transform. So we'll say transform is going to take in e. Now we need to define what these functions do. Self is extract. We're not just going to pass this. What we want to say is we want to extract all the clients from the city. So I should say what e equals to. I'm going to do the list comprehension thing. For each client in self clients, we passed that in earlier. We want to return C if we want to return that client if what's it? C, that's a dictionary, right? So city needs to be a literal to access the value of a key. So if city, we need to close that, is equals to city. Add the city in for this. Yeah, so if the city is what we want, then we just need to return that into the list, and there return the list down. So we should see all the people from New York at the end of this run. So I'm going to copy this, go this to our runner. Okay, no syntax errors, good. Oh wait, oh no, I did miss the city. I didn't know what city it was, so in this case, let's say New York. No typos, no spacing. Is that okay? So run this. Oh god, what happened? Transform takes one positional argument. Really? We don't even call it yet, but you know. These are everything listed. We have Kevo, New York, New York, New York. Okay, so the filter's working. Then we need to go to the transform portion of this. To copy this, go back into text so that we are not being spoiled by the IDE. Okay, I could not do that in 3 minutes. See how far we can go to finish this off. So for the transform, yeah, what we're trying to do in the transform is what we're trying to do with the transform. Transform. We need to access this first before we print it. We're going to pass in E. So that's the extracted clients from New York. We want to transform this into like a pair, because what we care about, what we're trying to access is we want clients that are based on the city. So extract help us with that. We're looking for group by name and age. So those are the two pairs of things we care about. So if it's name and age of a client from a city, I mean, there are different ways to sort of do this, right? I'm thinking of like the city, it could be a dictionary. Or do we need to put the do we need to add city as well? Well, I said name and age specifically. That's how we've done it before in the past with this drill. What do you think? Say print C instead. So we need to define this. We're going to go back to our function self, and we're going to pass in extract. We need to pass in the extracted clients from New York, which is the city we've entered, so that it can, enrich this. And we're going to iterate through this. It's going to be something like for E in extract. What do we want to do? We want to add this to a tuple, right? We define a tuple at first. Just say T equals to none, or T dot append. It's sort of like a list, right? Well, it has to be a list of tuples to begin. But the tuple itself is just one object. A simple pair. Okay. So T dot append. Let's do everything. The append to program in different languages. It's throwing me off. Let's assume so. So we want the age. We also want the what? Name. The client. So that. Return. T. Yeah, this should work. We should see a pair now. Copy that. Go to test run. Run this, see what transform gives us. Oh lord. E, the T, the this append takes exactly one argument, 2 given. Really? 2? Oh, I did not close it properly, or what? What happened? Oh, it needs to be, oh gosh. You see, this is why I prefer not to code in the IDE, because it's going to help you fix some things that you won't be conscious of, right? It needs to be like this. This nested parentheses, this first opening and closing bracket is the tuple. Then the outside one is representative of the, this is an argument for the append function. And there we go, okay, in age, so we've done that. So now load, all what's left. go to the load function. Let's define all that before we actually print it out. So load is going to take on transform. And we need to say load is equals to, what's a dictionary? We want to traverse the tuple, so say age, comma, name. Also, is this sorted? What part do we do the sorting? Sorted. Let's do the sorted now. So sorted takes in T, right? Yeah, I think we can sort iterable this way. By default, if it was just a list, an array instead of a tuple, we would be able to just pass this in like this, but we need to say key is equals to, key is how we want to transform this. We'll say, give it a headless function lambda, say x is equals to 0, which represents the first, element of the tuple, which is the age. So we want to sort this by age. So this should take care of that part. It seems it did so already. I don't want this to be misleading. So we are going to, like, for instance, how do we know this was sorted, right? We should switch it up. So I need to say Kevo is like older than Olivia, right? And Umi should be older than Olivia as well. So that way we make sure that it's actually going to sort, because they're already sorted by how they are inserted. So let's just say, I don't know, 25, and then instead of 24 here, say 20. Yeah. We have old, middle old, 20, and then we have 20. So it's this like descending order, right? So if this function is correct, this was done properly, we should it should be sorted properly once we go back to our run function here and this. Syntactically, is that right? Oh yeah, I did not finish this, did I? Good thing, noticed. We run this. Kevo's 19. Why is Kevo still at 19? Oh my, I'm silly. I didn't change the actual. I changed the comments, not the variable. We need to do this on the actual client itself here. I'll run this again. Try 5. 25, 21, and 20. That's sorted, right? Or should we use sort? I think sort is what does it in place. Sorted. What does this return? Oh, it does return a list. I see. Okay. So now this should work. We shouldn't see 25, 21, and 20. We should see 20, 21, 25. 20, 21, 25. Yep. Okay. Now sorting functions works. Got the sorting for the transform. Back. This. And now we need to do the grouping. So we're iterating through tuple for age, name in transform. What do we want to transform? Age, name, and transform. We want to say if. Let me look at the condition again. Group by name and age. So just the group by. So it needs to be like what? A key value pair of age and their names. If multiple people have the same age, they need to be paired. Let me just create another one. Umi is called Sam. Just so we can see if it's actually pairing together. So we say if age in L is our dictionary for the clients. Then we want to say let's initialize here, right? Because every age would need to be initialized. And then at the end of it, we need to access this age again. And since it's a list that we initialize, we want to append onto it. And that way, if in the case of Umi and Sam, they both have the same age, what would happen is the next time it iterates over to Sammy, it would go, oh, age already exists inside our dictionary, so we're going to just skip that and we'll append. Simply, the first append is like the initialization, and then the second one is the addition. And we just say name, right? Simple. Let's return this guy. Right. Oh, I did not print anything out. Let's print this. PTL transfer. PTL upload is equals to T. Let's see what it is now. This guy. Need to start closing these windows. Archive code close. Student sorting problem. I'll close that too. Run this, see if it works. No, I messed up. Key error 20. Huh? Key error 20. Let's see what's going on. And what line is this? Line 34. 34, so it's right here. So I'm saying L age, right? So get me this, which would have been initialized, right? And append that to the name. Yeah, so why is it confused? Because this, when we access this dictionary, this should be a list at this point. If 20 is inside the dictionary, wait. If 20 is inside the dictionary, we should say not in. So let me replay how this error would have happened. We have an empty dictionary at first. If age is in there, go ahead and blank it. No, that's like resetting it each time. So how come it's complaining about key error 20? So let's walk through this. The first time this would iterate through, we have in our transform, right, 20 for Umi. So that's that might be the first person. If 20 is inside here, no, 20 is not, so it's going to come inside here and it's going to say L.age, which is going to try and access the key that is 20, append. And so it would fail here because we never initialized the key age 20 inside the tuple to begin with. This is supposed to be if age not in, but if I wanted to do it the way we're doing it now, like if it's not initialized, go ahead and initialize it. The other way around this that would have made this work is if age is inside here, we need to append, right? Else, we go ahead and we do this, right? So like if, I think it's more proficient to have just one if we could. But this is what would have worked. Simply initialize, otherwise add. So if you run this again, we'll Ctrl F5. So 20, this is wrong. Why don't we see Olivia Cavill as well? Age is in L does append. Else, if we've not found it, initialize it, right? Okay. The issue with this is it's gonna initialize the first time always. We need to initialize then add at the same time, or forget initialization. I think I was thinking about this in terms of using not in. We simply just need to add name onto the list. Oh, this should work. That's at the bottom here, we see it. In order, 20, 21, 25. Okay, chilling. How long did that take so far? That was like 25, like 20 minutes. Sheesh. So now that we've got that done, we just do it all over again, but faster. Actually, let me give AI to review my ETL code. I should probably share my screen with that. Let's go to VS Code lookup. So lookup, I'm going to show where it's Chrome, Google Gemini. Yup. Code review, architectural guidance, troubleshooting, helping develop performance. The Python code. Python practices, general structure, readability, adoptions to class, hinting use type hints for arguments and return of values. Clarity of variable names. ETL are a bit too short. Okay. ETL process information. Init method is good. Why did they say that? Comprehension. Your person used the list comprehension, which is very Pythonic. Efficient for this task. Case sensitivity. ZFCT comparison should be case insensitive. If so, you convert CCT to lowercase before e.g. Okay. Then it gives, okay, so it gives the breakdown, then it's probably going to show an example later on at the bottom. Transform method, more Pythonic transformation. The current approach of appending to a list and then sorting is fine. However, you could directly create lists of tuples using a list comprehension as well. Okay, I see. Oh yeah, we could do that. Group logic revisited. Group logic. The problem statement mentioned group by name and age. The current transform method sorts by age, and the load method groups by age. If the intention was a group by both name and age before loading the transform step might look different, e.g. creating a key that combines name and age. instead of just a key that combines name and age. However, based on your load method, it seems the primary grouping is by age. Huh? Wait, let me read that again. Was to group by both name and age. Interesting. I guess the wording is different, but what would that look like to group by both name and age? And the names associated with that age are listed. This is a common interpretation. Load method collections.default. This is a prefect. Perfect use case of collections default dict. It simplifies the logic for adding items to a list within a dictionary, as you don't need to explicitly check if the key exists. Clarity of grouping, the outputs one clearly shows group by age. Wait. I did not give it the output, so this internally calculated, right? Oh my god, this might be smarter than ChatGPT. And this is right? Like if we compare, okay, look. Here's why I'm tripping a little bit. I need to ask this AI, did it actually internally run this? Because it says the output, so that means it probably ran Python, like had a Python run or something. Because all I gave it was the code I did, right? Yeah, I simply shared the IDE, so it knew that. Yep, I didn't share this part, which is the actual execution. And if we compare, let me compare actually. Let's actually compare, right? So if we paste this here, we go to Gemini AI, we go down, we copy this example that it gave for the output. Let's just test correctness, right? I'm going to highlight this with my IDE, my editor, right click. I'm going to go to compare with clipboard, and let's see if there's any difference. Okay, got it perfect. Wow, so it is smart enough to actually calculate. I'm not sure if ChatGPT does that too. I imagine it would, but the fact that it from all the prompt engineering I've been doing with AIs like Cloudy, ChatGPT, Gemini, now what impressed me is that it's not making assumptions. It actually ran my code, right? So that's something I definitely want to ask it. But let's finish the whole review process first, that we can get into. Interesting. Okay, Gemini is smart. Smarter than anticipated. If name equals the main block, example data, good to have clear example, output. The print statements are helpful for demonstration each step. So this is the improvement recommendation. Okay. I'm just putting doc strings in between. Okay, let's see what it did. Let me see if I like it or not. Self clients. So it's using type dict. Okay, so it's using dict typing. It's using more typing for explicitly initialize the ETL. An ETL extractor from load program to process clients' data. It extracts clients based on city, transforms the data by pairing age and name, and loads the data group by age. Okay. So what did it do here? Did the same thing I did, okay. But here's the typing. Added more typing. And it added the return type as well. Interesting. This dictionary. Tuple listed. Okay. Transform and extract data into this. So here I did list comprehension, right? Whereas, what did I do? I switched it last time. Okay. Also, I just realized OBS is not going to show my editor because I switched to the Gemini view for the code review. So I'm going to switch back. Oh, what's up, Shaq? I'm not sure how long you posted that, but I missed it. How you living though, twin? I need to switch my view. I need to switch the view back to, yeah, the code editor. So what I was talking about, if it did not make sense, is Gemini was smart enough to actually calculate this code, and it was right. We both have the same output. So the clipboard is what Gemini has, and then this is what I actually have on my IDE. So it ran the code, actually ran the code. Let's go back to Gemini and ask it. Did it actually run the code? Oh, you're here. Dang, Tony, how long have you been? A real lurker. So it improved the code, so that's nice. Specific things it did is it got specific with the typing, which is the type of data that's returned, and the type of data that we're going to add onto functions, right? But what I want to ask it, let's ask it something it did. How did you get this output below from your response? Did you run this or did you assume? How did you run it? I'm just curious. Then we can continue with the code review and some more context for support. No, I did not run the code in a live environment to get that output. I simulated the execution mentally. What the heck? I did not run the code in a live environment to get that output. I simulated the execution mentally based on the logic of your load method and the provided sample input data. What? It's simulated. Here's a breakdown of how I arrived at that example output. Input load from transform. After the extract transform starts with city, provided client's data, the transform method will return a list similar to this after sorting by age. So we just mentally knew, right? But here's what's interesting with AI. They can't, or maybe they can, infer, right? Because I executed this output and it was right. So what I'm curious right now is what is AI, or in this case Gemini's limitation on building things, you know? Because let's say this example it shows is wrong, which I've experienced before, because they make an assumption, right? And that assumption, they have a tendency to hold it as fact. What if that output was wrong, right? Like, let's say as someone, you're trying to solve something, you're not sure what you're doing. You see an example here that they give, but I guess to clarify, it did say this is an example. I'm just surprised / impressed and curious. The example was accurate. It was the actual output, you know. So I guess I need to ATD, attention to detail, on how it interprets things. If it says it's an example, I'll be like, okay, does this example make sense regardless of whether it's correct or not? I was sort of taking this example as correctness, but it's a simulation. It's a correct simulation from what it's describing, you know. Sheesh, man. Interesting. We got like what? 20 minutes? I want to do the mini, then I want to do the vanilla version of this code as well. Right. Let me ask it something better. Okay. First iteration, second iteration, okay. So for more support context, lead code. This ETL is an exercise drove. I don't know how to spell proficiency. Proficiency. Improvement. How does the does this ETL process here serve as a good model? To solve some such to solve some or most problems. Improve. So I for Python data structures, you're already using fundamental Python data structures, extract, transform, dates, tuples, dictionaries, hash maps, crucial for themselves, to use effectively in your transform step for pairs. Okay, basic algorithm, filtering slash searching. Filtering slash searching, the extract method uses a simpler linear scan. Sorting transform method uses sort, the lambda function, which is a common pattern. Grouping, so filtering and searching, sorting, grouping, or hashing. Demonstrate basic grouping logic using hash tables. Modular design, breaking down the problem into extract methods. This is a good software engineering practice to promote clean code, separation of concerns, which is often hidden assessment points in interviews, not just about getting right answers, but how well structured. Pythonic idioms, list comprehension, excellent. Currently limited in breadth of data structures and algorithms covered. Often dive into much wider range of concepts. How can it be improved? So you draw this daily. Diversify the ETL transformations and increase the complexity of the data structures and algorithms involved in each ETL step. Here's a structured approach for daily drilling with your ETL model. Okay, then. Phase 1, deepen current concept and Pythonic mastery. Refine current ETL with advanced Pythonic features. Could you use counter in some transform or load steps? Count occurrences of names or age. Okay, I like that. That is true. That does happen. To be a common use case for pattern or filtering or searching. Intertools module, explore intertools that group by, what is that? More sophisticated transform stage. Func tools that reduce for aggregation. While less common for simple ETL, understanding reduce can be useful for certain aggregations. Generators slash yield for very large data sets, extract and transform yield data rather than return full lists, saving memory. This introduces generator expressions and the yield keyword, time and space complexity analysis for every variation you implement. minimizes big O time space complexity. This is crucial for coding to use write comments in your code. Time complexity order n, space complexity order n. Add robustness and edge cases, input validation. What if client is empty? What if a client dictionary is missing? So that is all phase one, deepen current concepts of Python. Robustness and edge cases are the case sensitivity for city. Nullability, like there's no clients. What's a load? The current load handles duplicates ages by appending names. What if you needed to deduplicate clients based on ID? Deduplicate clients based on ID. Like let's say it's multiple people with the same name, right? Like Bob and then Bob Jr. Jr. is a middle name. His name is actually Bob. So we got two Bobs, senior and junior. This thing is actually thinking like that. Interesting. Now create new versions of additional methods with ETL process or new ETL process. Oh my goodness. Okay. I'm not gonna read through all this in time because I actually want to focus on building that proficiency, you know? So I'm going to, you know what? I'm going to probably for each of these things it's given me, I need you to give examples for each. I'm just going to put it that way. The goal is to drill on can you give an example? Each suggestions, comments, signifying sections of block code to be or you can provide three separate examples. You can provide well, I don't know if it's three. How many phases did it mention for improvement? Phase one, phase two, phase three. Focus on optimization and design patterns. I kind of just glanced through it. So phase one is what? It's my Pythonic stuff, right? So it's Pythonic concepts. Phase two is data structures and algorithm. And then phase three is design patterns. Provide separate examples for each phase, or even better, these three, one example that utilizes all the concepts. Let's have one separate example code for Okay, let's see. Okay, let's see it. It's cooking. It's cooking. We'll see. I'm gonna get myself a drink, and then I'll head back into it. But this should be done. I should be done in like 8 minutes. But I do want to do one more drill. We haven't done the mini yet. I should probably do the mini. I just got a message. I'm almost done. Hmm? Okay. I need to get back to you guys after. I'm almost done. But that's funny. So it's being mean. What's being mean? Um so let's see if it's smart enough to do that. But before it does it, let's finish. Let's try and finish strong. So I'm gonna close Gemini, go back to the ETL code that we're in, and I could honestly do this in two ways. I could do the mini, like strictly just do the mini, right? But that's going to be weird because the thing is, this mini. Okay, let's see. There's no ETL here. It's just straight code, right? Extract, transform, load, and then we're saying for age name transform. This is so much simpler, honestly. It's clean. So what do we need from here? You know what? Without looking, I'm not gonna look at that. I'm gonna just try and wing it. Talks class mini ETL. What do we need for a mini ETL? That's the question. Def. We need a constructor. We need to pass in the clients, right? I think that's pretty much it. Why should we need anything else? What's that in the clients? Self clients. We'll initialize the clients with this. At the end of this, we'll say if current function is equals to name, which means it's what we're actually running right now, just a driver. And we need to say class, so we don't need class again. I'll just say m mini etl is equals to mini etl. To cancel. I need to pass in those clients. Do I have it on my clipboard? Control Shift V. Where are those clients? New York. Yeah, let's see. These are the clients. And then we're just passing in simply these clients, right? We're passing these clients. I need to indent this, or it's going to give us a syntax error. So indent, go back up. So now we're going to have just one function called run. No ETL stuff. This is going to be the whole ETL itself. So we need self, and that's it. That's what oh, we need city as well. So I guess we can filter in the city. I don't know why in the mini one, the AI gave for an example, we had more than that. You know what I mean? We had like, it took in 3 arguments. So I dare to challenge that we don't need 3 arguments. What do we want from this? We want to call in run, which should return us just the groups of what we're looking for. Well, I need to put in like, what's it? Let's just say New York is the city. For consistency, and this needs to be, I'll just say output. That will print out the output, and that's it. Dang, I don't run out of time. Mini-ETL, this. Okay, so far good. We actually need to define our function now, so that has the city. And so in our E for extract, we're going to have our list comprehension. We're saying for, what's it, C, in self.clients, which we have initialized, if the city is equals to the city that we've passed into as an argument. So if the current client has the same city, then that's what we want to do. We want to return that client. So that's our extract, our transform. What are we doing in our transform? This can be an inline tuple. We need a list of tuple, right? So we need to say we want to copy this. We need the age and the name of the client. So age, name. That's a period, right? Used to be a comma. So again, for oh my god, let me give it a name that actually makes sense. I'll say extract. So for C, which is clients, yeah, I'll say C. For C and clients, in our extracted clients, what do we want to do? We simply just want to do that. Okay, cool. Then inside here, we want this sorted, right? I want to go sorted. I want to sort this by age. So sorted right now is taking our list of each client from New York's age and name. And then we are saying lambda x equals to age. I want to sort by age. So that's what we're doing right here. Is that good enough? It should be. So yeah, now we have our transform client, and then lastly is load, right? So load is going to be a dictionary. We're going to say for age, name, and clients. That's 6 minutes. Turn off my alarm. For age and name in what is and transform if age is not in load or loaded clients. I should do a better job naming things. That way it's easy for someone else reading it to follow. And for myself when I look back. If age is not inside a dictionary. You know what, I'll do that now. I'll just say load clients, age, comma, name. It's a longer name, but it's better to be descriptive than vague. So if the age is not inside our dictionary, this is what I was trying to do before. We want to initialize this, right? We want to say, oh, we're having a new client of we're iterating through this client. We don't have their age. There's a possibility that several clients have the same age. So we're just going to initialize this, right? So first thing is initialization. And the second thing to follow from that initialization is, I'm wondering, why is my indentation odd? Are you guys seeing this slightly? I'm going to end up having an error if it's too off. There we go. I don't know what it was. Was it a space? Anyway, we would not need an else. We just need to then append a client that already has the same age. What do we want to append? The name. So for the first instance of person, like this case, okay, Umi is age 20. We're going to initialize Umi, initialize the list that would then save Umi's age, right? And name. So should be a key value pair where the key is the age and then the value is a list of names So Umi and Sammy would be grouped again with this mini ETL process. And simply next, last not least thing to do is just to return the load clients. Yeah, hopefully this should work. So I'm going to move this from a text pad editor onto this actual thing. See if we missed anything. It does not like that. I'm not going to cheese and find out why it doesn't like that. I'll run it so we see an error, if any. Then we can go from there. Sorted, expected one argument got two. I was suspecting something was off. I couldn't tell what it was. Let's see. Expected one argument, but it got two. Why? This is a list, right? Hmm. I'm like, this should be right, right? Because we're passing in what it should sort. Do we close this properly? Yeah, let's close it. Ah, I think I see what this is. After the comma, we need to say key is equals to this. Syntactically, that's what it's looking for. Now let's run this. Okay, load. Something's off. Oh no, that's right, that's right. Let's just add one called Sammy. I want to see if it's actually pairing, right? Because that right now it's a list of single elements. If we run this again, we should see Sammy and Umi grouped because they have the same age. Okay, there we go. Noise. And that's it. Right, I'm gonna switch out. Go and get some games, get a drink. I'm trying to hit A's this season on my PC account. I don't know about doing double A's PlayStation. I think it's more important to do it on PC. But the thing is, if I want to do it again, I need to start playing the game earlier, like with bots, bot lobbies, and all that. So we're gonna switch over to my hero now, soon enough. I'm gonna check out Mayor Bearsy stream. Type in Mayor Bearsy, chat, check out the stream. Well, lastly, let's just recap. So we learned how to, well, we drilled doing an ETL process with standard Python with a class, separation of concerns using functions. We also learned how to do a simplified version of that using mini ETL, which is just helpful for drilling, while the vanilla one was helpful for best practice. Then we asked AI how to improve the standard ETL, like what can be done better so that we get more proficient in the way we process or we drill Python so that we have competency in coding interview problems or coding problems in general. Gave some good suggestions for 3 phases. One was Pythonic suggestions, the other was data structures and algorithms, the last one was design patterns and optimization over N time. The design pattern bit, I'm more curious what it means by that. So then we asked it to give us separate examples for each phase and then one example unifying all those examples together. And that's what we're about to review now. We'll pick up drilling these on the next stream, the next study stream, which is going to happen optimistically later on today. After I get some games in, work hard, play hard. Deep in current concepts of Python, high level, let's see what it's doing. Phase, targets, blah, blah, blah. I see it's using more dict types. There's more explanations here. Group name, first initial, load and count names. Okay, interesting. Load and count. Collections of counter all names. So I guess it's All names.extend names list. Advanced Pythonic features, collections counter. Okay, so new things I'm not aware of. Notice the transform data also counts the frequency of each name across all initials, demonstrating collections counter across all names. Interesting. So you say all names, which is our list. Name list, extend name list. Initial name list and transform data.items. What is that even doing? Transform data.items. Is that everything on the list? Initial name list. I need to look at the usage of this to probably understand how everything's working properly. So for the Pythonic bit, I can see we're using more like inbuilt packages from Python. At the top, we're also using more dict types. So I'll check that. Dictionary typing. And those functions introduce new data structures and algorithms through ETL variations. Okay. ETL phase 2 graph. Interesting. ETL process demonstrating graph traversal. Graph traversal are things I've been avoiding. This is going to be good. And also, like when the use cases for using a graph, breadth first search, also depth breadth search as well. It's important. Extract referrals by depth. Is that it? Well, this is breadth first search, so still BFS. Still BFS. Yeah, interesting. Transform to depth summary. It's sort of throwing me off. We say BFS, but it's doing a BFS instead. At least from the comments. Now that's going to be really good. But high level, it should put demonstrating graph traversal for analyzing a client's referral network. Interesting. Okay, because I was going to ask, like, what is the context of this ETL? Like, why does it exist? But it's still in the context of clients information, which is a very basic use case. Not basic use case, but common for businesses. If it's not clients, it could be students, you know, a group population, right? What are we doing with that? So one was filtering based on location, city. In this case now, with this phase example, it's what are their referrals? For students, it might be what are their, I don't know, categories or subjects, classes that they're subscribed to. What's the last bit? What is this? Example 2.2. Oh, there's multiple? Oh my goodness. Well, this thing went deep, man. 2.1 DFS slash BFS slash. So it put both. I'm gonna find out. I have questions on this definitely. Excuse me. Priority heaps. Mini heap to efficiently find the top K clients based on a specific criteria. Age. Heap sorting tool. Okay. Unified example utilizing multiple concepts in one ETL. This example is really so okay. Error handling, generator usage, and specific structures such algorithms like default jigs, intertools, and heaps. Extract clients from a specific city. Transform them by calculating a risk score. Simple aggregation, identifying the top n clients by risk score. Using a heap, grouping all clients by their first initial, case insensitive, load the top n clients and the overall client summary by initial. Okay. Man, this is work, man. Like, it makes sense. It's real world relative. Even though the whole point of me doing drills is to be proficient in the programming language, this is more detailed. All right. Good to know. So we'll probably drill each one, ask it questions, move over to the next one. It's like 3 things high level. for all of those phases. It's the Pythonic parts, which this is the easiest, you know. Should be able to get that done, make sense with it. And then the DFS and the heaps are more interesting. More interested in terms of the complex. Alright then. I can't believe I was saying all that, but I wasn't showing you what I was looking at. Oh my goodness. All that long talk. I need to find a way to share full screen with OBS. Or at least select screens to share. But these are the only two things I have running now. But this is what I was talking about. I was just reviewing this whole, hey, here's how your current studying proficiency can be improved. And it gave some examples that I prompted it to refine based on what I have. Okay. Now, for simplicity of me just reading with the comments. Did we use any depth first search? My referral depth. Find all kinds reachable from the starting point. Detecting cycles of referral as well. Okay, dubs. Alright, that's it. Overstudied. I'll catch you guys soon enough in the next game. I need to check my Discord. I know you guys left something, so let me slide back.